So it is scrolling or not actually?
Yes, sir. Scrolling, sir.
Okay. So, okay. So, uh, very good evening to all of you. So, today we will be covering the rest of the topic before our capstone project. So, this entire session will be in 4 or 5 parts. Initially, we will start with the AI project life cycle. Then we will go with Gen AI, that is generative AI, where we will discuss about generative adversarial network and transformer models. They are two basic, very widely used models. Then we will go for the industry 4.0 and its AI and its uses in industry 4.0. Then we will discuss the ethics and biasness in AI. That is what I plan to cover in today's topic or in today's presentation. Now, let's start with the so this is the basically overall topic that I will be covering in the AI life cycle. So let's start with the AI project life cycle. So basically AI project life cycle in this, what we can say, basically it's a 5 or 6 step process where we start with the problem scoping, because what's the AI project life cycle is basically, it's an entire process of finding the problem to designing its solution and to deploying the solution for the real world uses. That is the entire project AI project life cycle is. We have to first identify the problem, then we have to also find the its possible causes. Then we have to also find what type of solution we can design. Then we will model our solution. Then we will do some evaluation over our model solution. Then we will deploy it, and then we will do maintenance and rest of the things. That is the basic AI life cycle. So in broad terms, if we can say that it's a step-by-step process to solve a problem using given scientific methods. In this case, our scientific method will be the AI. Okay. Now, first one is the problem scoping. The first step is a problem scoping. Okay. Or in other terms, we can call it a problem definition, or we can call it a business understanding, or we can call it a problem understanding also. Then second is a data acquisition, where first we have to identify the problem. It's not only about the identification of problem also. It's the basically scope of problem also. We have to see the impact, see the information that from a problem we can get. Then based on that information, we can do the data acquisition. It's a basically database preparation process where we will collect data from the raw sources and we will create our data set. Then data exploration, or we can call it a exploratory data analysis also, EDA, where we will try to visualize the data so that we can analyze the pattern, what type of so we have to basically design a model now. So if we want to design a model randomly, we can't pick. We need to visualize the data so that we can find out the pattern, what type of data it is, how patterns are there, how data have been overlapped, or data are uniquely exclusive. That we have to identify in the data exploration process. Then based on the data exploration process, we have to do the modeling. Once model has been designed, we will do training and validation. That will be the performance evaluation part. Okay, we will train a model and we will validate a model. Then we will evaluate the performance using so many matrices are there. We have precision, recall, F score, we have ROC, AUC. If it's a regression type of a problem, then we have a mean square error, R squared error, mean average error, mean absolute error. If it's a kind of a generative problem, then intersection over union is there. So many types of evaluation is there. It will be based on our problem. Okay. Now, once evaluation has been done and we are satisfied with the problem, then we will deploy the problem. We will deploy our AI project into the real world scenario. After the deployment, there is one more phase called maintenance. So up to evaluation, we consider it's a life cycle, because the deployment and maintenance, it's a basically loop process. Now, let's start with the first one is it's a basically the steps of AI project life cycle. Problem scoping is there. Once problem scoping is there, we have to, in problem scoping, we have to identify 4 Ws: who, what, where, and why. I will discuss what is this. Then we will go for data acquisition, where we have to identify our sources and we have to collect the data. At the same time, we have to prepare our data also. Okay, so in this step, we have to do 2 things. One is the data preparation part is there, and another one is the data cleaning part is there. We will see. Then there is a data exploration or exploratory data analysis is there. We will be having so many tools and so many methods to visualize the data. We will use everything. Then we will go for a model where we have to choose which type of learning we have to perform, whether we have to go with a rule-based system, or if we don't, if we want to go with the AI system, then what kind of a problem it is. If it's a regression type of problem or classification type of problem, if it's a, basically it will be suitable for supervised, semi-supervised, or unsupervised type of problem, whether it's a reinforcement type of problem or not. We will decide in this step. Once the model has been developed, we will train it and then we will evaluate it. So it's a basic stages of our AI project life cycle or AI project cycle. Now, the first one is that is called problem scoping. So what is a problem scoping actually? Basically, problem scoping deals with 4 W's: who, what, where, and why. In one word, we can say that who are facing the problem, we have to identify. So basically, who are facing the problem is we have to find out the environment of the problem. Okay, where we have to identify who are the stakeholders, those are facing the problem, for which we have to give a problem solution. Now, second, what is the problem we have to identify, and third, where is the problem and why is that problem. So these 4 things we have to identify. So basically, this problem scoping is what we have to just get used to with the problem, and we have to sometimes we have to identify a problem having a vision to solve it. Okay, because based on this 4 W's, we can only able to decide whether a problem is solvable or not. Okay, now let's start with the 4 W's. First, who refers to that who is facing a problem and who are the stakeholders of the problem. Now let's take an example. Then if we are talking about crop yield production problem. Okay, we have to maximize the crop yield production. So basically, how we can maximize it? By finding or by predicting a suitable time for seeding, and finding a suitable best time for fertilizers use, and for finding a best time to cut the crop. Okay, that are the some. It is just a simple scenario. Then in this case, who refers to the farmers, because farmers are facing the problem because they are having there are so many diseases in the plant, the crops are not growing well, so many problems are there. So in that case, who will be referred to the farmers. Okay, and what will be refers to the what kind of a problem we have to solve, because in this case we have to maximize the yield production, crop yield production. So that will be our problem. Where is that problem? So where basically it can be a scenario, it can be a situation, it can be an environment, or it can be a location. So in this case, the problem is in the fields, crop fields. So that will be our where position. And why refers to the why we need to solve the problem, because if crop production is not good, then farmer will be losing their profits, they will be in loss, and farmers daily life depends on the crop production, na? So it will be very difficult for them to survive. So these 4 W's basically decides whether a problem is solvable or not, and what is the basically what we call it, what is the basically impact of that problem, solution, impact of the solution to the society. That will be decided by why. Okay, now so first, if these 4 P's has been already decided, who is the problem, second, what is the problem, sorry, who is facing the problem, what are the problems, where the problem is having, and why that given thing is a problem. If we have the answer to these 4 W's, okay, then we have to prepare a template. So basically, template is what? So template is kind of a summary or problem statement of our based on our 4 W's. Okay, it will consist all the information, all the key points that we have collected. Okay, it's a basically kind of a all the necessary details you need to know. Okay, these are basically templates explaining all the key points in a single template. Okay, it's basically it will give you all the basic information of a problem. Okay, now let's first thing, now let's how to identify a problem. Okay, so if you want to solve a problem, first you need to identify. If you want to solve a real life problem, first you need to identify that problem. Now, so a problem can be identified by choosing the environment first. So you need to identify the scope, or what we call it, theme. Okay, first you need to identify the theme. So there are so many themes. For example, environment is a theme. Okay, agriculture is another theme. In case of environment, what can be a theme? what can be a problem? Environment, for example, production of a CO2 and its implication on global warming. So there are so many things. If you have a real-time data, then you can literally predict the effect of CO2 in global warming. Okay, environment. For agriculture, what kind of a problem is there? You have to detect the disease in the leaves. Okay, you have to maximize the crop yield production. Okay, you have to identify best time to do seeding. Okay, you have to basically, you can use sensor and everything to monitor the moisture and every moisture and humidity and temperature within or nutrition values in the soil, so that you can give fertilizers. There are so many problems in traffic. Basically traffic analysis is another problem. Okay, where lane finding is there. Then because right now people are fascinated about uh, that automatic vehicles, na, driverless vehicles. Okay, so traffic analysis is there. Okay, infrastructure is there, health is there. In health, so many disease detection is there. Okay, then in case of security, we have to detect bots, we have to detect malware threats. Okay, in education we have to use AI, because in education field we can use teleprompters, we can use smart boards. Okay, then digital literacy is there, women safety is there. These are some these are just examples of themes, okay, where we can identify a problem. Okay, now let's select a theme. Okay, let's say if we are selecting agriculture as a theme, then yield rate, okay, basically yield production will be a problem. Okay, sowing and harvesting pattern will be another problem. If we are talking about digital literacy, online learning platforms, digital awareness, ebooks, all these are problems where we can ebooks, basically we can, from ebooks we can generate question answering. Okay, health is, if we are considering health environment, then medical aid. Okay, medicinal aid, mobile medications, spreading of a disease, identifying a disease. Okay, classifying a disease, segmentation, basically denoising. So many things are there in health. Okay, now let's select a theme. In this case, if we have selected agriculture as a theme, and we are selecting a topic, sowing and harvesting patterns. Okay, so we have selected agriculture, and is in within the agriculture there can be so many topics. Okay, so we have to choose one topic. I have selected the sowing and harvesting patterns. So within this topic we have to list out all the problems, determine what will be a good time for seeding, determine what will be a good time for harvesting, determine when and how much fertilizers will be applied on a selected crop. Okay, determine what kind of a disease has been affected to the crop, so that we can use a specific type of fertilizers. So many problems are there. We have to list out all the problems. Okay, once this has been done, then we have to select one problem. Okay, based on that we have to create 4 W's. First, who. So who basically helps you to analyze people getting affected directly or indirectly due to that problem. Those will be who's. In this case, farmers will be our stakeholders, and they will be affected from our problem. Okay, so basically stakeholders can be people who are facing the problem and would be benefited with the solution. Okay, this is first W. Second, in who basically answers these two type of question. Who are the stakeholders? In this case, farmers are our stakeholder, fertilizer producers are also stakeholders, laborers, tractor companies are our stakeholders. And then second is, what do you know about them? So these are some of the people most affected by the problems and losing their money and time. This is what we know about them, about farmers, fertilizer producer, laborers, and tractor companies. Okay, so these type of question will be answered with this who. Okay, then what. So basically in this what category, we have to identify what is the problem and what do you know and how do you know about the problem. These two things we need to identify. Okay, now you can identify the problem via newspaper, via media, via announcements. There are so many examples where you can find out the problems. Okay, now what answers two things. First, what is a problem? So because basically we have to determine the what type of problem we have to solve. Now in this case we have to we are looking into the seeding or crop harvesting, na? So finding out the best time for seeding and best time for harvesting, that will be our problem. Okay, how do you know about this problem? So seeding is at seeding at improper position and imperfect time leads to the wastage of money and time. Okay, because how do you know about this problem? Now we have to identify what we have selected, it's actually a problem and it is affecting people. Now in this case, if improper seeding and if the seeding time is not good and we are doing the seeding, then there is a chance that there will be less crop and indirectly farmers will be affected. That's why it's a problem. Okay, Now where is the problem? In this case we a problem look where basically deals with the, it focuses on a context or a situation or a location of the problem. In this case we have selected agriculture as our problem now. Then the where basically gives you the location, that is a field. Okay, now it gives you the what is the context and situation in which stakeholders experience the problem. So basically it's a basically we are talking about the crop field where we have to decide the mature age of the crop and determine its time so that we can do the harvesting. Okay, that is the where. Okay, where is the problem located? It is in the field. Okay, now let's do the problem scoping for why it is a problem basically. So in why we give you answer about the if the problem is not solved, then how it is affecting the people. That's all. That's why the what we have selected is a problem. Okay, so basically you have to finally list down all the major elements that affect the problem directly. Okay, now in this case if we are not finding the best time to seeding and not finding best time for harvesting, indirectly the farmer will lose their money. There will be less production. Due to less production there will be less profit, and sometimes they may lose their profit also. Okay, that's why it's a problem. Now it answers why will this solution be valuable to the stockholder, because if we can find out the best time for seeding and best time for harvesting, then it will give you the maximum crop yield. Okay, at the same time if it gives the maximum yield, so the profit will be maximum. That's why it is our solution will benefit the stakeholders. Okay, these are 4 P's. Okay, first, farmers. Stakeholders are farmer, fertilizer producer, label, tractor companies. Okay, these are who. And what basically deals with the problem, issue and need. Determine what will be a good time for seeding and crop harvesting. That will be what. When will be basically context, situation or location. Decide a mature age for the crop and determine its time. That will be our when. And why basically solution, why basically deals with the solution benefits. Okay, take the crop on the time and supply against the market demand on time, so it will be basically give you the maximum profit. So these are 4 W's in that we answer in the problem scoping. Okay, now second is a data acquisition. Now what is the data? So data can be structured data, it can be unstructured data. Okay, so data in this, if we have selected crop yield production, so in that case what can be a data? Data can be the soil condition. Okay, it can be the images or sensor data from the crop fields. Okay, it can be the video footages from the crop field, so that you can check whether the crop has been affected from any disease or not. So these are data. Okay, so data will be basically it's a raw information that you gathered related to your problem. Okay, so data can have 2 types. It can be a structured data, it can be a unstructured data. Now let's discuss about this structured and unstructured data. Now if we are talking about a structured data, then structured data are categorized in a quantitative way. Okay, so all the information that we provide in a structured data will be having quantitative information. It will be a numerical values. Okay, it will be arranged on a predefined format. Okay, so basically for example, a structured data can have name, age, address. Let's say if we are doing some prediction about cricket, then cricket scoreboard is there, school timetable can be there. Everything that can be represented in a tabular format in a like a Excel or CSV file, that falls under the structured data category. Okay, so in other words we can say that if we have extracted feature from a raw data and we have represented the features into the tabular representation, then that will be a structured data. Okay, now let's discuss about the unstructured data. So what is the unstructured data? Is basically unstructured data is most likely a qualitative data. Okay, so a qualitative data means a data that we can visualize, we can see, but quantitatively we cannot represent. Now for example, image, if we are taking 2 images of a same field, then there may not be a specific correlation between them. Okay, these are randomly taken images. Okay, so images doesn't have any structure. Okay, although they have some correlation between their near pixels, but they are not basically structured data. Okay, if we are taking, let's say, scrapped material from a website, it will be a textual information, so it will be unstructured data. Okay, so unstructured data is a data that can't be processed or analyzed using conventional relational database methods. RDBMS methods cannot be used to analyze those data then the data will be unstructured data. Okay, so some example of unstructured data include text. It can be a video, it can be a audio, it can be a mobile activity. Mobile activity, it means in our mobile there are three sensors. Na? Mostly all the mobiles are having three sensors: gyroscope, magnetometer is there, then linear acceleration, accelerometer is there. So analyzing those data, okay, so that to identify whether a legitimate person has been holding or mobile or not. And mobile activity in terms of scrolling or web activity is also there. Then social media activity is there, satellite imagery is there, surveillance imagery is there. So these are list of examples which falls under unstructured data category. Okay, so up to this portion it is clear. Now, so how the data has been divided into two parts: structured data and unstructured data. Now first you have to identify, based on your problem, you have to collect a data. So you have to identify whether you are going to collect a structured data or unstructured data. Now let's say if you have to just predict, you have to just let's say identify the disease that has been spreaded over your crops. Okay, so what you will take, you will take pictures of the crop so that you can identify the disease portion and you can classify it into the predefined disease category, so that you can identify the fertilizers that has to be used in your field. Okay, crop field. So that falls under, basically that falls under your unstructured data. Now let's say if you want to basically check for best time for harvesting or best time for seeding, then you will take all the values. For example, you have to basically take the soil moisture, soil nutritional values, then temperature, humidity, other environmental conditions. So it all will be put into basically a tabular representation that will fall under the structured data category. So based on the problem, you have to identify whether your data will be a structured data or unstructured data. Okay, so based on that, you have to create your data set. So basically data set is nothing but it's a collection of data that you have collected in form of unstructured or form of a structure. Okay, so sometimes it will be a tabular representation. If you are using unstructured data, then it will be a tabular representation. If you are using a unstructured data, then it will be collection of your text, collection of your images, collection of your videos, or collection of your sensor information. It will be those data. Okay, now if it's a structured data and if you are representing in a tabular form, okay, so all the columns, okay, basically all the rows will be basically member to a data set, and all the columns will represent a unique information or unique feature regarding your data. Okay, so basically in these rows can be, it can be height, weight, temperature, volume. These can be related to your crop. Okay, now these are the data set and you have to prepare a data. Now let's say if you are using the what we can say, if you have to identify the disease, then your data set will be consisting of images of diseased plant and of normal plants. Okay, so you will collect samples of images from diseased plant that will be affected with a particular disease. Let's say disease 1 or disease 2. Okay, you have to collect images for disease 1, disease 2, put them into different folder, and you have to also sometime you have to collect the normal images also. In that way you can create 3 different groups: disease 1 group, disease 2 group, disease 3 group. Collectively this will create your data set. Okay, now this is a data set. Now it's a data acquisition. It's an example of just a structured data where we have given the name of a student, attendance in terms of percentage, gender is there or not, participation in sports or not, total marks obtained by them. These are structured format. Okay, now then the data, once data has been let's say acquired and you have prepared the data set, then you have to divide the data set into training and testing data, or we can call it testing data. Can be divided into 2 parts also: validation and testing. So generally we call it a validation data. Testing data is the data set which is unknown. Testing data basically is the data that is not known to your model. We will test in unknown data. That's why we call it testing. It's basically a validation part. Okay, a training data, basically training data is what? It's a basically larger portion of your data set that will be used to train your model. Okay, so that's why we call it a training data. Okay, usually the most appropriate way is taking 80% of your entire data set, and the validation part is it's a part of a data that you are going to validate the performance of your trained model. Usually we take it to 20%. It's up to you, it depends. Okay, you can take 60-40, you can take 70-30, you can take 2/3, 1/3, you can take 80-20. In some cases even we can take 90-10 also. Okay, So that's called data acquisition, and it's a data preparation. Now, if data has been unstructured data, okay, now let's say what is the data features. So I have already explained in first lecture, okay, our deep learning models doesn't need features, but if we are training on a machine learning models, then we need data features. Okay, why? Because the machine learning model is not capable of extracting features from the unstructured data. Okay, so basically data features are referred to the type of data we want to collect. Okay, it's a measurable piece of data that can be used for analysis. Measures it sometimes variables and attributes, what kind of feature you want to put. And if you have to collect the unstructured data and you have to prepare it for a machine learning model, then you have to do some feature extraction, feature engineering, so that you will extract unique features and put them in a CSV format, so that CSV can be used for your model training. Okay, so that is the data feature. Now, some data sources are, you can take surveys, you can take web scraping, you can take data from the sensors. If it's a sensor related, IoT related problem, you can take cameras. So basically, if it's a image related problem, then you can take pictures and you can take images. It can be observation values, or it can be a API generated data. These are some data sources where you can collect the data. Okay, now let's stay. Now next is the data exploration, or we can call it a exploratory data analysis. Okay, so why we need exploratory data analysis? Okay, and why we need to explore the data? Because we have to choose a model now. So our main task is to give a solution for a given problem. Okay, and for that we need to know the pattern that are present within the data. Okay, that's why we need to visualize. Okay, so basically data exploration is done to visualize the data, so that you can visualize the pattern that is existing within the data. Okay, if the data is more overlapped, okay, there is a, here you can plot heat maps between all the features. Okay, you can use area graphs, you can use bar chart, you can use pie chart, you can plot the histogram also, you can plot line graphs, scatter plot, flow chart. So many techniques are there. Okay, you can use it. Okay, so basically in exploratory data analysis, we have to basically check the behavior of a data. Okay, so that based on that behavior we can choose a model. Okay, it's basically just a previous stage where we can choose our model. Okay, it's a basically strategy that we are planning for a solution, so that it will be dependent on the pattern of a data. Okay, what pattern lies within the data, we have to analyze it, we have to visualize it. Based on that, we have to provide the solution. That's why we have to do exploratory data analysis. Okay, now during the exploratory data analysis, we have to do two things. First one is known as data cleaning. Second one is known as data visualization. Now, what is the data cleaning? Is basically, in data cleaning is a process of getting rid from commonly found errors or mistaken information or mistaken features. Okay, so there are three kinds of a mistaken or commonly found errors. First one is known as outliers. Second one is known as missing data, and third one is known as erroneous data. Now, what is the outliers basically? Okay, so why outliers is important also we need to know. Now we have done a scattered plotting of our data. Okay, we have chosen our data, we have done a scattered plotting. Okay, now look at here, all the data follow a trend or pattern. Okay, it's like all are aligned in a 45-degree line. Okay, but this one data point, it's a separate, it's basically different from all other, so its behavior is entirely different from all other. Now when these type of outliers are present, and let's say their outliers are in many numbers, okay, and we are using these outliers to train a model, then it will affect the performance of a model. Okay, so what we will do, we will simply eliminate these outliers. Okay, so basically what is the outlier here? Outlier is a point, or it's a basically information or a data that behaves differently from all other collected data or all other present information. So that's why we call it outliers. Okay, so we have to eliminate it. So that's why we need to do data visualization, because from numerical, by seeing the numerical CSV file, you can't analyze now, you can't tell whether the point or given a data is outlier or not. That's why we need EDA, okay, exploratory data analysis. Now, second thing, we have to tackle the missing data points also. So what is the missing data point? In sometimes when we extract features, all the all are quantitative values. If we doesn't find any features in that place, in CSV file we used to CSV file used to give a value called nan. Okay, that is a basically not a number or unidentified information. So we have to get rid of nan value. Okay, so to get rid of nan value, there are so many techniques. Either you can delete entire row, but that is not suitable. So generally what we used to do, we used to take a average from one upper value and one lower value. Now let's say if an nan value present in this position in a table representation, then we take just one position upper and one position lower side and take average of it. Okay, or we can take a mean of that row, that column. We can take a mean values of that column and put a nan value as a mean of entire column. Or at the same time, what we can do, we can take a frequency of most occurring value in this column, and we can put it in a nan value. So there are so many things. And erroneous data is incorrect data points, so we have to eliminate these incorrect data points. So these are things that we used to do in exploratory data analysis. One is data cleaning and another one is a data visualization. Now let's say missing data is there. Now let's say this is an example. Now this is a missing data, this is a missing data, this is a missing data. This is a missing data. So nan values are missing data. So what we can do is we can take average of all these values, 10, 20 and 30, and whatever average we are getting, we can put it in a nan. Okay, at the same time here we can take it average of these three. Okay, and we can put it here. Now let's say if there are values in bit after this D row, then we can take average of these three, and just the things that are present in the E row, we can take average of these two also. So there are so many techniques through which we can handle the missing data, but deleting the missing data is inappropriate. Okay, now next thing is a modeling, or we can call it a model selection. So based on our problem, we have to choose what type of model we have to give. Now let's say if we have to decide the time, what will be the perfect time to harvest the crop. Okay, then that time will be a regression problem, because we have to predict a continuous information. That will be a basically regression problem. Okay, now let's suppose if we have to identify the what we call it disease of a plant. Okay, so plant can be a disease, can be disease A, disease B, disease C, disease D. Okay, so it will be a classification problem. So based on a problem, we have to model our solution. Okay, it can be a regression problem where we have to predict a continuous value. It can be a classification problem where we have to basically find out the class in which our input is belonging. Okay, it can be a disease detection, or it can be whether you can get a whether your whatever crop you have entered, you can get a maximum profit from it or not. Okay, so another one is a clustering based problem where we have to just identify the outliers and we have to make clusters. Okay, and it can be a deep learning related problem. Okay, so first, based on the problem, we have to choose based on what AI model we want to develop, whether it's a rule based. So if it's a rule based, it means, let's say if we have visualized the data, it is following a specific pattern. Okay, so whatever violating that pattern will be eliminated. Okay, so we can set a rule. Okay, based on that rule, it will be a rule based model. Then we have to choose if it's a rule based solution cannot be appropriate for our problem, then we can go with a learning based problem. It can be a deep learning based problem, it can be a machine learning based problem. So based on learning problem has been divided into three categories. Okay, supervised learning, you all of must you have known it. Okay, supervised learning can be a classification or regression task. Similarly, unsupervised learning can be a clustering or dimensionality reduction task, and reinforcement learning is there. Okay, in some cases semi-supervised learning is there. If it's a medical related problem, then we will go with a semi-supervised learning also. So these are the ways through which we will design a solution. Okay, once model has been designed, then we will do training based on our training samples, and we will evaluate the performance of model based on our validation test. Okay, if you are having any doubt, you can ask me. Just a second. Somebody has wrote some messages. Okay, rule based AI model is there, but very few people are using it. My screen is visible now. Okay, now let's discuss. Okay, we were in the evaluation. Okay, now what model we have selected, Based on that, we have to design our evaluation strategy also. Now, let's say if it's a classification type of a problem, then we will go with the accuracy, precision, F-score, recall. I believe all of you are familiar with accuracy, precision, recall, and F-score. Okay, that's why I'm not diving deep into these things. Okay, now let's say if it's a classification-based problem, then these four matrices we use to find out: accuracy, precision, recall, and F-score. Okay. Apart from this, we try to plot the confusion matrix. We try to plot the RSE curve, that is receiver operating curve. Okay. We try to plot the AUC, area under curve. Based on, if it's a deep learning related problem, then we will try to visualize the pattern also of training loss or validation loss, and training accuracy and validation accuracy, to analyze whether overfitting is there or not, or underfitting is there or not. Okay, so these are evaluation strategy for a classification problem. Let's say if it's a regression problem, then you have to find out the errors. Okay, it can be a mean square error, it can be a mean absolute error, it can be a root mean square error, it can be a R squared error or adjusted R square error. Okay, these are the parameter matrices that we used to do in classification regression. If it's a generation type of problem, we have to generate some raw information from another information, like generative AI. Okay, then we have to, there are some other also. For example, it's if it's a segmentation problem or image generation problem is there, then we can go with the F-score, precision, recall, accuracy. Along with that, one important thing is that IOU, intersection over union, is there. So based on problem, you have to choose your evaluation matrices. Okay, if your model is showing a good results in all the matrices, then you can say that your model is good and you can deploy it. So basically, deployment is basically where you can deploy. You can basically, let's say if in our case we have to check a disease of, let's say if we have to check the disease of a plant. So what we can, where we can deploy, we can deploy it in a web page. Okay, we can create a mobile application, mobile app. Okay, we can deploy it. Okay, we can deploy it using APIs. Okay, so you can, if it's a real time of problem, sensor based problem, you can deploy it on hardware and you can install it to a field. Okay, so based on that, you have to deploy it. Okay, once deployment is over, then you have to monitor and maintain. What is a monitoring and maintenance? First thing, because there are so many cases now, because your model will be trained on known data only, and you are not sure that your data will be sufficient for every scenario. So when time changes, data also changes. Okay, so you have to take care of that. You have to perform retraining and you have to like evolve your model. That's fall under maintenance. It's basically a looping thing. Okay, you have to retrain again through larger data set, so that your model will be more generalized. Okay, that will be your maintenance part. Okay, so it's total AI project life cycle. Let's now try to understand one real life case. Okay, now it's basically a development of low cost AI system for a prediction of bone mineral density from plain radiographic images. That is, it's a live project that I am working on. Okay, it's a basically ICMR funded project. Okay, now first, how we come up with this problem. Okay, that is the first thing that comes under problem scoping na, कि हमें ये प्रॉब्लम मिला कैसे आखिर. Okay, so that we can get a sanction. Okay, of we can get a fund from ICMR. Okay, so I have connected with a doctor. Okay, so we discussed about the real life problems in medical field. So he was an orthopedician. Okay, so he suggested some problems. Okay, we have identified problem related to bone. So we from entire ortho we had dropped down to bone only. Then from bone we drop down to, or we narrow down to hip only. Okay, then we find out that there is one problem that is called osteoporosis. Okay, so what is the osteoporosis actually? It's a basically weakness in bone structure. Okay, we are having bones. Okay, in bone is basically, it's a calcium and mineral deposit. It's like a rigid sponge. Okay, all of you have seen a sponge. In a sponge, it's a porous structure. Okay, there will be holes, but everything will be interconnected. Now assume that it's a porous structure, but it's a rigid. Now what happens in osteoporosis? The bone mineral density will be lower. Okay, so lower means the joints will be very smaller. So if you, let's say if you apply some pressure in your bone will be so fragile that it will break. Okay, now the main problem is what? It is a very severe bone disease, but it is not visible. Okay, it's basically silent disease. And you won't believe that out of 3 women post menopause, it means above age 50, there are chances that two of them will be suffering from osteoporosis suddenly, and it is not visible. You will suddenly fall from a bathroom and you will see that your hip has been fractured. Okay, and it will be a lifelong complications. Okay, so that's why we have defined the problem, that we have to detect the osteoporosis. Okay, that was our problem. Now what will be the our who here? Who is basically all the patients. Okay, then what was the way? Second thing, what is the problem is basically bone mineral density prediction. Okay, why? Because to detect bone mineral density, you have to literally do a DEXA scan. It's like a MRI scan. Okay, it's a very expensive and it is not available easily. You won't believe that in entire Bhubaneswar or entire Bhubaneswar, I think 2 DEXA machines are there. Okay, and in remote areas or it is not available. In entire Jharkhand, there was one DEXA machine at Dhanbad. Right now, it is there is two, one in AIIMS Deoghar. Okay, so it is so expensive and so immovable that you can't find the DEXA everywhere. Okay, so that's why screening of this osteoporosis is not possible. So that's why we have come up with a problem that we have to predict the osteoporosis from the X-ray images also. Okay, then we have identified the persons and age groups. Okay, so we have collected data from these 4 places. So data will be what? So that we have decided 4 Ws. Okay, then we have done data acquisition. So data acquisition has been done from AIIMS Delhi, AIIMS Raipur, AIIMS Bhubaneswar, AIIMS Deoghar, so that 4 different regions will be covered and different age groups will be covered. Okay, and what data we have collected? It was a basically structure and non-structure combination. We have collected X-ray image, and along with we have collected their DEXA scan values so that we can predict the BMD score, that is called T score. Okay, so we have paired it. Okay, now that's why we have, so based on that we have collected 10,000 X-ray images labeled with their T score value. Okay, now based on that we have taken a X-ray image with a BMD score. We have taken an X-ray image. We have done some pre-processing. ROI extraction is there. Then we have done we have proposed our techniques to predict. It's a basically regression type of task. Okay, so we have analyzed, we have basically we have what we have created. We have created a hybrid model here. So based on problem we have to give the solution na? So basically it's a hybrid model where we have used two. We have feature engineering, we have done feature engineering as well as we have done deep learning based both. Okay, at the same time at the top we have used support vector regression. So it's basically 3 different things: handcrafted feature, deep learning, and machine learning based classification or regression. Okay, so based on that we have predicted from X-ray, we try to predict the BMD score. Then there is a rule based system that predicted BMD score will be gone to a rule based system where it will track the threshold value based on the given pre-existing or existing information, whether the T score value falls in the category of osteoporosis or osteopenia or normal. Based on that we are checking whether the bone is healthy or not. Okay, so this was a real life problem. Okay, now let's discuss the second part, that is the generative AI and large language model. Up to this part it is clear. If you are having any doubt you can ask me. Okay, up to this portion it is clear. Okay, now let's start. So now, second. Just a second. So we were at Gen AI. Just a second. Okay. Now in Gen AI, basically we will be covering generative AI. Okay, GPT, Gen, and diffusion models are there. Application of generative AI we will see. We will see the emerging trends, limitation, and potential of our Gen AI. Okay, now let's start with the generative AI. So what is a generative AI actually is? Okay, so basically generative AI refers to the class of AI systems that can create new content. Okay, that's why we call it a generative AI. So AI means artificial intelligence, generative, that can generate a new content. Okay, so basically generative AI, it it falls under that class where we can take training information, and we can, from the training information, we can synthesize the new content. That content can be a text information, it can be literally a program code, it can be a image, it can be a video, it can be a music, it can be a any other kind of a data, it can be a prediction information, and literally it can be a question answer also. You can, it can be a prompting where you can give a question to prompt, and that prompt will give you the answer based on your training. Okay, so that is called generative AI. Okay, so basically it will be, so how it will do, it will learn the patterns from the existing data. Okay, and based on the pattern it will give you the answer. That answer can be a new content, or it can be a question of your answer. Sorry, it can be answer to your question. Okay, so that is a generative AI. So the core idea behind generative idea is that, let's say if we are taking a text information only. Okay, so if we are training the on text, then generating a sentence will be the your generative AI. Okay, if you are training on an image, then generating another image like a Ghibli art. Okay, like from your image, raw image, to generating a cartoon. Okay, from a raw image to generating a sketch art, that will be a that will be another generative AI problem. Now let's say if you are training on a music, then composing melodies will be another example of generative AI. Okay, now, so basically generative AI, okay, it can be a text, it can be image, it can be audio, it can be video. These are our input information, or we can call it our training data, where we can train our models. Okay, and it will be like more like a prompting, where we can input text, image, audio, video information, and in result, for from text also we can generate image, audio, video. Okay, it can be a multi mapping, many to many mapping. Okay, from images you can generate text, from audio you can generate text, from video also you can generate text. Okay, so prompting is what you will write your question here, and the AI model, based on its learning, let's say it has been learned on text, then it will give you a textual answer. Okay, if it has been learned on an image, then it will give a image based answer. If it has been learned on an audio signal, it will give you audio answer. If it has been learned on a video, then it will give you a video type of answer. If it has been learned on everything, then it can give you a combination of everything. Okay, so it's a basically, what are the AIs till now we have seen na? Those were discriminative AI. So discriminative AI means it will try to predict something, or it will try to classify something. So those are based discrimination based. Okay, they will discriminate, or they will try to find out the pattern which will be different in all cases. Okay, now in case of a generative AI, it will simply try to generate a new content from its own content, or learned value, learned info, whatever information it has been learned. Okay, now the, let's say for example, what are the, where this generative AI lies. Okay, we have this artificial intelligence block is there. Okay, so AI, the capabilities of machine to compute or imitate intelligent human behavior is there. So basically, you know now where AI is, where machine learning is, where deep learning is. Okay, and the generative AI is, it's a combination of all. It is a AI, it can be a deep learning, it can be a machine learning, and it can even sometime it can be a rule based also. Okay, within the generative AI, basically we work on three type of a models. One is known as transformer based model. For example, chat gpt na. So chat gpt means generative pre-trained transformer. Okay, it's a transformer type of a model, and when we are using transformer model na, so it will give you more like a text information. Okay, then there is a auto encoders, it's like a question answering. Okay, and we have one more thing that is called GAN. Okay, generative adversarial network. So these two are widely used, GPT model and generative adversarial network. This generative adversarial network, it can literally synthesis everything from raw image to text. Okay, and this transformer model, it is mostly for the text. Okay, so Gen AI leverages these three things: transformer based thing, Gen based things, and variational in autoencoder based things. Okay, apart from this, there are so many other generative AIs also. Okay, but based on learning, it will try to basically leverage to leverage its learning to generate new content. Okay, this is the position where Gen AI stands. Okay, now what are the common examples of Gen AI, where we can use Gen AI? We can use it for video generation. Okay, we can also use it for software development. We can literally write codes. Okay, we can use it for voice generation. We can use it for healthcare application. we can use it for text generation, we can use it for gaming, okay, we can use it for finance, we can use it for image generation. So these are common example, okay, where we can use this Gen AI. Okay, up to this portion, it is clear. Now, let's. These are some common tools of generative AI. First is the Chat GPT. Okay, we all are familiar with this Chat GPT. Okay, then we have Bing AI. Bing AI developed by Microsoft. It's just like a Chat GPT question answering thing. Okay, then we have Google Bard. Okay, Google Bard is developed by Google, and we have some other GPT models like Notion is there, Jasper is there, Dali is there, and so many other models are there. Okay, now let's just second. Huh. How does this generative AI actually works? Okay, so generative AI works. It can, if you are using a GPT model, that is a generative pre-trained transformer. Okay, it will create text response. Okay, so how it will create text response? Basically, it has been pre-trained now. So whatever, let's say, if you are giving input to your GPT model, it will tokenize it. It will try to identify the keywords. Based on keywords, it will uses billions of text file to respond. Whatever we are using pre-trained model now, it has been trained on a billions of text information. Based on that keyword, it try to find and it try to write, okay, based on some patterns, based on some keyword extracted from your input, it will try to write output, okay, based on transformer model. Okay, so basically generative AI is, it can be most of the time it relies on two things. One is a GAN based, if you are dealing with the image, that is generative adversarial network. If you are dealing with, let's say, text based information, then it will be a transformer model. We will discuss transformer model in a deep. Okay, up to this portion it is clear. If you are having any doubt, you can ask me. Okay, now let's say how this generative AI works. Step one. Now I am taking GPT as a example. Okay, now user inputs a prompt or question into GPT prompt. Okay, it's a Chat GPT, it's a generative pre-trained transformer. So transformer, it means it will deal with the text. Okay, so let's say we have prompted that write a 150 word essay on the impression movement in 19th century France and its characteristics. Okay, that we have written. Okay, now what happens in the second stage? The GPT, okay, uses deep learning algorithm to analyze the prompt and generate the response. Okay, now how it generates the response? Okay, what the GPT model, how it will do, it will identify the keywords and phrases in the prompt. So how it will identify? First it will tokenize, it will do lemmatization, it will do stemming. Okay, it will do all the NLP techniques. Okay, no, generally don't do, because the models that we are using is far better than that our LSTM or what we have seen. Okay, so it will try to, the transformer model basically takes two. It's a transformer model. It takes two type of input. First one is a word sequence and its position embedding also. So position in which the word is occurring and the word itself. So it will, from that, it will try to identify the keyword phrases in the prompt. Okay, now from that, it has taken the command write a essay in 150 words. So it has divided the entire prompt into two parts. One as a command, another one as a topic. Okay, so command it has taken as a write an essay in 150 word, and topic it has selected as a impressionism characteristic 19th century France. So it has taken these two. Okay, now in fourth stage, the GPT addresses or accesses, the GPT searches its database for the information to find out the relevance information related to these two. Okay, first it has it got that it has to write 150 words. Okay, so it has been identified, the task it has to do is it has to write or it has to generate 150 words output. Okay, and the output should be related to these two topics. Okay, so that GPT accesses its database, okay, to find out the relevant information related to this topic. Okay, so what does it know about the writing essay? Okay, what does it know about the time, century, characteristics, and any movement has been done or not? So based on the information, in fifth step, it uses NLP technique. NLP technique, it means it will generate the text, okay, from one text to another text to another text. So it will write sentences, phrases, okay, that's which are grammatically correct and contextually relevant to the whatever prompt has been given to that prompt. Okay, whatever question has been given to the prompt, it will be relevant to that. So based on that, it will try to generate 150 words. Okay, once these word has been generated, in the next step, what it will do, it will give that output in the prompt window. Okay, so that output will be visible to you. Okay, up to this point it is clear. Okay, now let's see. It's a basically GPT 3.5. Okay, now look at here, write an 150 word essay on a moment in 9th century France and its characteristics. So it has the written. So it will start word first. It has been started with the impersonisms. Okay, then it will try to write entire word one by one. Okay, so this is another example. Now, where we can use this generative AI function, language and content generation, where we can create content, many types, including code. Okay, then we can do information retrieval. From information retrieval, we can literally put paragraph, and we can find out the keywords, or we can retrieve in important points from the paragraph. We can do language translation, we can do text summarization, we can do writing assistance also, we can do conversational assistance also, where we can literally conversate with the AI. Okay, these are some common functions of generative AI. Okay, now this GPT is basically why we are right now using GPT. Okay, that is generative pre-trained transformer. So earlier, before GPT, we were using CNN, RNN, LSTM. So we have already discussed CNN and RNN in our first lecture, na? And one advanced topic was LSTM. Okay, so LSTM is most related to the text generation. Okay, so these three, CNN, RNN, and LSTM. CNN deals with the images, RNN, LSTM mostly deals with the LSTM. Now, what happens in case of a CNN is CNN can extract it basically deals with unstructured data, na? Okay, with images or videos. Okay, it is good for a feature localization. It will extract feature. It will try to identify the feature from low level features to abstract feature or semantic features. Okay, but where it lacks is there will be no dependency in the data. Why? Because we know, na, in CNN there will be no memory. CNN doesn't have memory. It uses just combination of filters. Okay, it uses only filters, na. So that's why it doesn't have a memory, so it can't remember. If it can't remember, so it cannot generate a data from whatever it has learned, from the information it has stored. It can't generate the data. What it can do, it can just try to find the pattern. Based on the pattern, it can discriminate. Okay, so CNN does not have a mechanism to understand or order of element, making it harder for a problem involving text and time series. Okay, it doesn't have any mechanism to understand the pattern and to establish the long dependency. Okay, so CNN fails. Now let's talk about the RNN, especially LSTM. It's a long short-term memory. It's a just advanced version of LSTM. So it's basically deals with the remembering long dependencies. Okay, so LSTM can handle long range dependency due to their ability to process data sequentially. Okay, but in case of if a sequence is longer, now let's say if it's a one sentence sequence, now so LSTM will work fine. Okay, now let's say if we are giving an input entire page. Okay, so there will be very long range dependency. Now what happens in case of LSTM? It suffers with the vanishing gradient problem. So what is the vanishing gradient problem? All of you must have already discussed during CNN. Now, when the error will be there, then the gradient of error will be back propagated to train the model, to update the weight. Okay. Now, in case of LSTM, most of the time we are using 10H. Okay, 10H activation function and sigmoid activation function. So these two activation function are responsible for vanishing gradient problem. It means the gradient will be vanished. Okay, vanished, it means when gradient will be adjusted from the top layers, the layers that are near to output, to the initial layers, the gradient will become 0 or nearly 0. So the initial layer won't get updated. So it won't get trained. Okay, that's why this LSTM is suffering from this vanishing gradient problem. So that's why RNN, CNN, LSTM are suitable for a specific data type. Okay, for example, RNN is suitable for images. CNN is suitable for images. RNN and LSTM are suitable for short text type of things. Okay, not long text dependency. Okay, that's why we are using generative pre-trained transformers, GPT models. We will see what is this GPT. Okay, later. Then we have this motivation behind GPT is this: a new architecture called transformer is proposed by the Google, okay, which avoids that recurrent connection altogether. Okay, this GPT model, rather than taking word by word, okay, what LSTM or RNN does, na, we have already seen that it takes one word at a time and try to predict the next word. Okay, so it will be very difficult to difficult. Okay, what transformer does? Transformer take entire sentence at a time. Okay, but it also takes the position encoding also, which word occurring at which position. It is taking both. It will take entire sentence as an input, as well as at the same time it will take positional embeddings also. That's why this GPT works better. Okay, now we have another that is called generative adversarial network. Okay, we will be discussing these two things. We will discuss in detail the transformer model, and we will discuss in detail this generative adversarial network. Okay, we will discuss both. Now, generative adversarial network is basically, it's a generative adversarial and network. So generative means we have to generate something. Adversarial is a type of a learning, and network, it's a basically deep learning architecture. This gen can be divided into two parts: generative adversarial network. Okay, so what is a generative? So generative, basically generative, we have two things in gen architecture or generative adversarial network architecture. We have two things. One is called generator, another one is called discriminator. We will discuss it in detail also. So generator's work is to generate the information. Let's say if we have to generate a fake image, na, so generator will try to generate fake image. Discriminator is the role of discriminator is what? Is to discriminate between real and fake. So what it will discriminate? Whatever generator generate, it will pass the information to discriminator, and discriminator try to differentiate between the real and fake, because generator will generate the fake information. Okay, now discriminator will try to predict whether it's a fake or real. It's a kind of let's say it's a generator is a kind of artist, or let's say we can say a con man. He will be trying to replicate a currency. Okay, generator is what a person trying to replicate a currency. So he will create a fake currency. That currency will be passed to a, let's say a stakeholder, or let's say a person who has that capability to discriminate between the original and fake currency. Okay, we can call it a crime investigator. Okay, or a detective. Okay, so he will tell now whether the currency is true or real or fake. Now if the currency is real, okay, then the discriminator has to update, because it has failed to discriminate. Okay, if the currency is fake, then the detective or the discriminator will tell the generator that whatever you have generated is fake, you have need to update. So based on that, the generator will be updated. So this is a basically this type of learning where discriminator generates generator generates, discriminator try to detect. Based on the detected information, generator will adjust its weights and try to generate again. So it's kind of continuous loop. It's called adversarial learning. Okay, so in adversarial objectives, there is a these two network, that is a generator network and discriminator network, are basically compete each other. Okay, so what will be the competition? Generator wants to fail the discriminator, and discriminator wants to fail the generator. So it means generator objective is to generate a fake image that will be so real that discriminator can't discriminate, and the discriminator objective is to, it has to discriminate between the fake and real. If the fake is evenly, or if it is looking exactly like a real, so that is a discriminator. So this is a generative AI, the gen based generative AI. So it's a more like a it's a more like it mostly deals with images and videos. Okay, so we will discuss it later in detail. Then we have this diffusion model is there. So basically diffusion model is another class of generative model where it works by adding noise in the images in the training data, called, it's a forward diffusion process. Okay, then based on that, it will try to reverse or recover the original image using the reverse diffusion model. We will see it detail also. Okay, so diffusion model, we have diffusion probabilistic model, unit architecture is there, latent text encoding is there, classifier free guidance is there. Okay, so we will discuss these three in detail. Okay, now let's take an example. Okay, it's a DALI example. So basically DALI is a prompting where we have just given a command that generate a 30 render of an astronaut walking in a green desert. So look at here how it has generated. It was a iteration 1, it was a iteration 2, it was a iteration 3, it was a final iteration. So it has generated the output like this. Another example is there where gold bar is chilling on the beach. So these are common output. Now, what is a major problem? Look at here. So whenever in first pass it gives this output, another pass it gives this, another when you write you try to give this same command, it will generate this output. It will try to give this command again, then it will generate this output. So there are so many different output for the same command. That is called hallucination. Okay, it means our model will hallucinate. It will try to generate output that will be different, entirely different from each other. Okay, we will, that is a major problem with this gen AI. Okay, now look at here, it's a basically gold bar chilling on a beach. So look at here, we have 4 different examples. Okay, all are entirely different. It's called hallucination of AI or gen AI. It's another example. It's a mid journey where gold bars are chilling on a beach. Okay, so we will application we have already discussed. Okay, this is a GPT chat GPT example where you can literally interact with the GPT. Okay, now these are some uh, different types of generative AI. First one is a generative adversarial network. Then we have variational autoencoders. We have auto regressive models. We have diffusion model. We have transformer based model. We have flow based model. But out of these 6 models, 2 are widely used: generative adversarial network and transformer based model. And we will discuss these 2 models in detail. Okay, now let's start with these are the type of generative AI models. If it's a large language model, so if it's a LLM, so it means it will be a transformer based model. Okay, so large language model, it's a transformer based model. So typical output will be in form of text, code, dialogues. Okay, example GPT T5, these are example. If it is a gen based model, generative adversarial network, then it will be type of output will be image and video. Style gen, big gen is there. Okay, it's a variational autoencoders, then output will be in form of a images and structured data. Okay, for example, VE models in PyTorch. PyTorch is having this variational autoencoder. Okay, if it's a diffusion model, then the output will be form of a image, art. For example, DALI 2 is there, stable diffusion model is there. If it's an auto-regressive model, then output will be in form of text and audio. Okay, for example, GPT, WebNet. If it's a multi-model, so multi-model, it will be a combination of many things. Okay, it can be a combination of a transformer again, VAE, diffusion, or auto-regressive. So it can be the typical output can be text and image also. It can be actions also. So examples are Plami and Flamingo. So these are common different types of generative AI models. Okay, up to this point, it is clear. If you are having any doubt, you can ask me. Up to this point, it is clear, all of you? Okay, now let's start with the generative adversarial network first. Just give me a second. Okay, so what is a generative adversarial network is basically? So basically generative gen, okay, are model that generate new realistic data, okay, by learning from existing data. Okay, it has been introduced by Goodfellow in 2014. Okay, so basically generative adversarial network, it can create new data that will be similar to real world data. Okay, that is the generative AI, or sorry, that is the generative adversarial network. Okay, we will see. Look at, it's a original paper of Ken where these are, look at here, these are the original images here, these are the original images. Okay, and these are the generated output. It will look exactly similar to this. Okay, these are the original images, these are the fake ones. These are the original images, these are the fake ones. These are the original images, these are the fake ones. And in 2014 it has been introduced. Okay, look at here, GAN progression is in 2014 it was capable of producing this type of image only. Blurry, look at here also the previous example in 2014 it was introduced na? So all the examples, it was perfect for the numeric na? It's a MNIST data set where it is perfectly working. When we are talking about faces and natural images, then the output are not that good, but still it was able to generate images. Okay, look at here, in 2014 it was generating blurry type of image. In 2015 somewhat images has been improved. 16 further improvement has been done. 17 further improvement has been done, and 18 it has started to generate realistic data. And in 2026 Now it is generating that kind of a data that we can't even say that, or we can't even tell that whether it's a real or fake. Okay, it's a GAN progression. Now this is the another during the 2018 star GAN was proposed. Okay, now look at here. These are the input. Okay, so we have taken input. Now these are the generated images. Look at here. From this input images, they have generated this. They have the input, they have given blonde hair, so hair has been changed to blonde. Then gender change, then gender has been changed from male to female, female to male. Then they have aged it, then they have done pale skin. Look at here. From input you have taken, you have done the emotions. From same input we have tried to generate an angry face, happy face, fearful face. So this is the generative adversarial network. Okay, capability of Gen AI. Okay, now this is the progressive growing of again in 2018. Look at here. This was the output. Okay, we will see how it will be generated. Okay, now let's deep dive into the architecture of the GAN. Now, this is the basic architecture of GAN. It's a generator and we have a discriminator. Okay, now what generator will do? Generator will generate the data. Discriminator will check whether it's a real data or fake data. Okay, so how discriminator will check whether it's a generated data is real or fake? So the discriminator will be trained on a real data. Okay, now let's say if you have to generate the numbers, okay, from, for example, this MNIST data set. If we are talking about this MNIST data set, then this will be our real data set. Okay, this will be our training samples. Okay, up to this portion, and these are the generated. Okay, so our discriminator, look at here, this our discriminator model is this model will be trained on a real data. So why we are training it on a real data? Okay, so that it can tell whether the whatever data it is getting as an input, that is real or fake. So that's why discriminator will be trained on a real data. Okay, how it will, the training process works. Generator will take a random noise. It can be a mean noise, median noise, or Gaussian noise. Similarly, at the starting point, a generator will take a noise information. Okay, based on some noise, this noise value, it will try to generate a one iteration of a data. It will generate some data. Okay, that data will be fed to the discriminator. Okay, that discriminator will now check whether the given data is true or false, or real or fake. Now in initial iteration, we know now the data has been generated from a noise, so it will be far away from the real data. So discriminator will tell that generator, you are fool, you can't generate the real data. This is the problem. Okay, that's feedback, that error will be given as a feedback to generator. Based on that, generator will adapt its weight, and based on the adapted weight, it will again try to regenerate the data. Okay, again discriminator will discriminate it, and this process will go into the loop until this discriminator will fail to distinguish between the real and fake. That is the convergence point. Okay, so generator tries to produce the realistic fake data from the noise, and discriminator tries to distinguish between real data and fake data. That is the goal. Okay, now look at here. This is the given distribution, input x and y. Now discriminative model learns conditional distribution. It's a discriminative model. Okay, known x. So known x means it's a training sample, and y is basically whatever input we are giving from the generator. Okay, so basically it's a conditional probability. It will check whether the check for the known information, because it is already trained now on the real data. So based on the real data, it will check whatever data given as an input and probability or having that input as a real. Okay, it will check conditional probability. Okay, and this generative model, it will try to learn the joint probability. Joint probability means the given feed, it has generated y earlier, and the information from discriminator will be given x. So based on these two information, it will try to generate the joint probability. Okay, so these are the discriminative and generative models. We will see it detail. Okay, now let's take a basic example. Okay, so this generator as well as the what we call it, our discriminator, both are neural network. Okay, now assume that generator is a kind of a reverse neural network. Okay, so reverse neural network means we have seen CNN. In initial layer, we will be having an input layer that will be kind of looking like a matrix. Okay, at last we will be trying to classify whether in one or two classes. So it will be like a pyramidal structure. Here a larger information, a larger matrix will be there, which will be narrow down to a smaller information. Now the generator is just reverse of it. Okay, we got a smaller information and we have to from that generate the image. Okay, so it's kind of a reverse CNN. Okay, and discriminator is a original CNN. Okay, now this generator will take a vector. So vector can be it's a basically a numerical information. We call it a latent vector. Okay, so latent vector, it means latent vector. Now how you can say that All of you remember the CNN model na? In CNN model, last layer we are having fully connected layer. Okay, so based on the fully connected layer, that fully connected, after that we will be having softmax layer na, to predict. Okay, that fully connected layer will be having the vector. Okay, you can remember this vector as a fully connected layer input. Okay, so it will be having vector, or we can call it features. Okay, so initial, at the first iteration, this will be random noises. Okay, based on the random noises, the generator will be reverse engineer. From, assume that it, from here it is a softmax layer for classification, it is just before that our fully connected layer input. Okay, it's a vector representation, or we can call it a feature. Based on that, we will try to generate the matrix representation. From matrix to another matrix to, we will try to reconstruct the image itself. Okay, so this is a neural network in reverse order. Okay, so from a vector we will generate an image, so it will be a matrix representation. Now let's take an example how actually happens. Now let's say it will be a kind of a numerical information. Let's say it's a numerical information. Now each dimension of input vector represents some characteristic. Now you cannot know, it's basically, it is unknown key what value represent to what characteristics. Now look at here. Now let's say it's here is a white. Now you don't know key for which parameter or which feature the white here has been generated. It is not known. Now let's say you have changes this 0.12, just we have updated that value to 3. Okay, based on the feedback. Okay, now look at here, the hair has been longer. Okay, now again we have changed, let's suppose the same vector was initially, we have changed it to 2.4. So look at here, the hair has been blue. Now we have changed that bottom one to 3.5, that mouth has been open. Okay, so based on this random iteration, it will try to learn. So look at here, if from these 4 example we can understand now. Now let's say if we are passing these 3, okay, we are passing 2.4 and we are passing 3.5 in a vector na. So we know na, we will be having longer blue hair with an open mouth. We know from generator now knows na ki with this value it this will be generated. After some iteration there will be some changes na, in generator there will be some update and the value will be changed, this input vector will be changed. Okay, and that new updation had will this 3. Okay, so from this 3 it will be, now generator will know that hair can grow longer and we can generate longer hair with by updating this value. Okay, after some time, after some iteration, generator will know that by updating this value we can generate blue hair, and after some time we can generate a open mouth. Now let us suppose if we get a query that we have to generate a longer hair, longer blue hair with an open mouth, then generator already knows now that he has to pass 3, 2.4 and 3.5. Okay, so what it does actually, it takes a random, initialize, it start with a random latent vector z. Okay, and this generator function try to predict x. X is an image. Okay, and that image must be looking like original one. And in this vector, every single information may correspond to an entirely different characteristic in the generated image. That is the generator part. Okay, up to this point it is clear. Now let's look at here. Now that was the generator part. Now how discriminator try to launch? Look at here. So image has been generated. Okay, now discriminator is a and CNN model. So you know now what is a CNN model. It will take image as an input. Okay, and it will try to extract all the features and go to the softmax layer and try to predict the probability of its having a real value, a real image or fake image. And its target is to maximize the chances of getting real information or real, to discriminate the real image. Okay, it try to maximize the class real. Okay, now image will be passed from generator to discriminator. This discriminator will do series of convolutional operation. It will try to extract the feature. Based on the feature, at last it will try to predict the probability whether it is belonging to the real class or fake class. Okay, now let's say if discriminator getting output as a 0.1, okay, so it means it's a real class. Discriminator getting 0.1, it's a real class. Now look at here, discriminator getting 0.1 value, it means it's a near to 0 value. So probability is 0.1, so it means it is near, chance is there, it's a mostly fake value. Now look at here, what will be the probability in this case? It will be more like a fake, na, because you can check na, discriminator has been already trained to distinguish the anime cartoons. Okay, it has been trained on these images. Okay, it knows how anime looks like. In this case, when this pattern doesn't matches with this pattern, na, so it generally give an output near to 0. So it is saying that it is fake. In this case, it will say that it will fake. So this is how discriminator and generator works. Okay, up to this point it is clear. If you are having any doubt, you can ask me. Now let's see the actual architecture. So this is generator architecture. Look at here. Random input will be given to the generator. Generator will generate the fake image. That fake image along with the real image will be given to the discriminator. Now it's a during training process. Okay. Generator we will use during the discriminator generate. It's a basically our target is to generate na fake image. Na. So in training process, we will give input, random input initially, okay, to generate fake image, and the discriminator will take fake image and real image both, okay, so that it can distinguish between, it will be trained on these two, so that it can distinguish between real and fake. So if it is given as a real, then it's thumbs up, there will be nothing, no change. If it's detected as a fake, then it will tell the this discrim generator that whatever you have generated, it was fake, you need to update. Okay, so it's a kind of a back propagation algorithm. Okay, so error will be back propagated. Based on that, it will update itself and it will try to generate another. Now let's say in some cases it passes, then generator update itself, sorry, discriminator will update itself. So it's a basic architecture of generative adversarial network. Okay, now let's take another example. It's a real images. Okay, now it's a generator version, it's a discriminator version. So real images will be fed to the discriminator version. Now it's a 3 versions. Okay, 3 version means we are talking about 3 iteration of a training. Okay, now look at here. In the first iteration, what happens? It will take a random noise as an input and it will generate this image. Now look at here. From vector, it has generated an image. Okay, for fixed size matrix representation. So it will look something like this. Maybe it will be random noises. There won't be any specific pattern. You can't identify whether it's an anime character or not. Now let us assume that it has generated this. Now this will pass to the discriminator. Now this discriminator will tell now, because it has already trained on this images, so it will tell it's a fake images. Okay, so it will tell fake images. Okay, so that image, that feedback, okay, will given to the this NM generator version 2. Now this version 2 will update itself. It will update its latent vector. Okay, based on that vector, it will try to generate another set of example or another set of fake images. It will pass to the discriminator. Discriminator will again tell that it's a fake, you need to update. It will update its way again. Okay, again, so it will generate another set of examples. Discriminator will tell whether it's a real or fake. If it's a fake, it will tell generator that it's a fake, you need to update. So based on that, this is the training process. That's why we call it a adversarial training. Okay, because these two will compete each other. Generator will compete with the discriminator. Discriminator will compete with the generator. How they are competing? Generator is trying to generate a fake image so real that discriminator can't distinguish. Okay, and discriminator is competing that it can differentiate it. It can tell an image which is looking just alike to a original image as a fake. Okay, so that's why we call it a adversarial learning. Okay, now look at here. If we try to analyze, look at here, generator 1 and so discriminator 1. Okay, now how they have, generator 1 has generated, discriminator 1 has checked, na, there was no AI, no eyes, so discriminator tell that it's a basically fake images. Now in generator 2, version 2 generated this. Okay, so discriminator now know na, there is a no mouth. Okay, so no mouth, then there is a chance that it's a fake image. In generator version 3, then it has done both. Na? Initially it said no eyes were there, so it has incorporated AIs, or it has included AI. So now no mouth were there, so it's not about no eyes, no mouth. A vector position will be updated. Now I have already said, demonstrated one example where one position can affect entire image. Okay, so it will change, it will be those updates. Okay, so no mouth means now it has been, the mouth is there. Okay, so in this way, this generative adversarial network will learn. At last, when it will converge, when the discriminator fails to check whether the generated image is real or fake. At that point, the GAN will, generative adversarial network will stop. That will be the convergence point. Okay, now it's a generator model. So basically, generator model is what? The generator model, it's a basically deep neural network that takes random noises as the input and generates realistic data that looks more, it's more like a data samples like images or text. Okay, now generator loss function is there. So basically it's a generator loss function, and we are having one loss function for a what we call it, discriminator. So basically the loss function for discriminator is a binary cross entropy, because that has to work binary classification, real and fake. So now in this case it's a loss function, so I'm not going deep into this loss function detail. Okay, that's a discriminator loss function. Look at here, this first portion, it's for the real and it's for the fake. Okay, its target is to maximize this so that it will be minimized. Okay, it is his targets. Okay, okay, so it's a discriminator. It's a basically, it's nothing but it's a binary cross entropy function that has been designed. Now look at here, what dxi does here. So basically dxi is, look at here, dzi is here. Zi, it is our latent vector that we have given as an input, and this g is nothing but it's a generated information. It's a generated image from this zi. Okay, now in this case the dxi, it means it's a xi is what, the input given from the generator to discriminator, that is the xi. And look at here, xi, sorry, this xi is a original image set. Okay, at this gzi, na, g is a generator output and zi is a latent vector. So based on the vector, it has generated a one image, na. So that image is here. Okay, so that's why it basically gives you the fake part, it gives you the real part, and it's basically jointly it creates a binary cross entropy. Okay, so up to this point it is clear. Okay, now this is the min max loss function, and it is the basic theme behind the what we call it, generative adversarial network. So why we call it a min max loss function? Because generator try to maximize the probability for identifying the fake images, and at the same time, sorry, discriminator try to maximize its probability to finding the fake images, and at the same time generator try to minimize the accuracy of discriminator. That's why we call it a min max loss function. Okay, this is the min max loss function. I'm not going deep into this. Okay, so this entire process, is called adversarial learning, where generators try to minimize the accuracy of discriminator. So minimizing accuracy of discriminator, it means discriminator will fail to detect the real and fake, and the discriminator's aim is to maximize its chances to detect the fake and real. So that's why we call it a min max loss function. Okay, up to this point it is clear. Okay, up to this point it is clear, or if you are having any doubt, you can ask me. Okay, now it's a working of generative adversarial network. Okay, so there will be it's a 6-step process. Generator will first move. Okay, discriminator's turns, adversarial learning is there, generator improvement is there, discriminator's adaptation is there, training progression is there. Okay, now let's start with the first and second. Okay, so what is the generator first move basically? So generator is start, look at here, it's just looking like the last layer of your CNN model, na? Okay, it is a fully connected layer type of thing, na? So it's a vector. So vector, we call, in other terms, we can call it a feature vector. Okay, so here Z represents a latent vector Z. Okay, and it's the output of generator. So we will write it Z. Okay, now look at here. We have given some random noises here. It will be a random information, random noises. Okay, so the generator start with a random noise vector like a random numbers simply. Okay, it uses this noise as a starting point to create fake data samples such as generated images. Okay, the generator internal layers transform this noise or this random vectors into something that look like a matrix representation or real data. Okay, it will be it's a kind of reverse engineering, generating an image from the feature itself. Now let's say if we will update a single position here, na, the entire image will be changed. I have already given the example. No? So this is the generator moves. Now discriminator turns is what? So what discriminator does here? Look at here. The discriminator will take real data from the real data set. Like in this case, it's a 349. It's a MNIST data set, na? And take fake data from the generated from the generator. Okay, these two will be given as an input to the discriminator. And discriminator is another neural network. It's a feed forward neural network. Okay, so we will start with the input layer and we will try to predict whether the output is real or fake. So it's kind of a binary classification task. So the discriminator try to distinguish real data from the fake data and output the probability. And its task is to maximize the probability of this real. It has to identify the real so that the rest of the thing will be fake. Okay, so discriminator, the real sample from the actual training data set will take, and fake samples created from the generator it will take. And this discriminator's job is to analyze each input and find whether it's a real and or something that has been generated or cooked up from the discriminator. Okay, so up to this point it is clear, or if you are having any doubt you can ask me. Up to this point it is clear. Okay, now let's do the adversarial learning. So what is the adversarial learning? Look at here. We have a generator, we have a discriminator. A generator will generate fake data. Okay, so each time, each pass, it will generate a better fake data so that it can try to fool the discriminator. And if discriminator gets fooled, then it will improvise itself, okay, based on the training samples. So improve detection to check the fake data. Okay, they will compete each other's against. It's a zero-sum game. Okay, so that is called adversarial learning. So discriminator correctly classify the real or fake data, and generator try to fool the discriminator by creating fake data looking just like a real. That's called adversarial learning. Now, how generator will be improved? Look at here how generator will be improved. Okay, so it's a improved fake data. Na? Okay, sorry, how generator will be improved. So basically, once it has been detected as a fake data, that the feedback will be given to the generator. That based on that feedback, it will update its latent vector. Okay, latent vector will be updated, and based on that, another fake data will be created, and that fake data will be given as a input to your discriminator again. So it's a continuous process. Okay, so look at here, discriminator adaptation is there and training progression is there. So look at here. So once real, again it will take the, so before that it generator improved na, and it has created another fake data. Okay, that fake data along with the real data, it will given as an input to the discriminator again. It will try to predict the real and fake both. Okay, so this training process will go on. It will again, if we detect real and fake, then it give the feedback to the generator. Okay, so that it can generate a better fake data. So it's a basically it's a looping process. Look at here, poor quality, easy to detect; better quality, harder to detect; high quality, harder to detect. So generator real. So when the realistic data has been generated at the, I think in thousand of it, after thousand iteration, and our discriminator cannot easily distinguish and fail to distinguish, then this is called converged. This is the convergence point. Okay, so it's a basically how look at here. It's a training iteration. We call it mean max. Na, look at here. It's a performance. Now look at here. It's a generator loss is decreasing. It's a discriminator loss increasing. That's why we call it a mean max problem. Okay, our task is to, the generator loss is decreasing. Then the data we are generating is more like a fake data. That's why our discriminator is getting error. Na, it is not correctly identifying. That's why its error is increasing, or loss is increasing, and its loss is decreasing. That's why we call it a mean max problem. So up to this point, it is clear. Or if you are having any doubt, you can ask me. Just give me a second. Okay, now let's move ahead. So these are three questions. So why generator cannot learn by itself? The first question arises. So can you tell me, anyone, why generator cannot be learn itself? Because generator doesn't know now what is real and call. Generator has to generate na. Generator का काम सिर्फ इतना that it has to generate a fake data. Okay, but it doesn't know what is real and what is fake, because the generator has been not trained on a real data. That real data we have used on a discriminator. That's why generator cannot learn itself. It needs a teacher. Okay, that will tell whether whatever you have generated is a real or fake. Okay, why discriminator cannot generate object itself? Okay, because discriminator is a classifier. Na, it will just, it has been designed to detect whether the real or fake classify. That's why it cannot generate object itself. So how discriminator and generator interact with each other? Can you tell me how generator and this will interact each other? Anyone can say? So that is the adversarial training process. Na, how they interact? The generator will generate something. It will pass information to discriminator. Discriminator will tell it's real or fake. Based on that, it will give the feedback to generator, and it's a looping process. That's how they are interacting with each other. Okay, so up to this point it is clear. If you are having any doubt till this point, you can call, you can ask me. Now let's take an live example. Okay, let's take an example. It's an anime face generation. After 100 update, it means it has been started with a random noise, and we have passed, we call it 100 epoch. Okay, after 100 update, look at here what it is looking like. So assume that in first iteration, what it will be given as output, it will be nothing but just random noises. Okay, so based in after 100 update, it is giving some face like a structure. Look at this, after 1000 updates, it is giving something like anime cartoon, but still mouth and other details are not there. Okay, look at here, this is the after 2000 updates, it is more improved. After 5000 updates, In some cases we are not getting mouth, but in some cases we are getting mouth, but the positions are very different. Look at here, these cases, this cases, there is no mouth. Look at here, after 10,000 updates, now it is more looking like a anime character, but it is hallucinating. Look at here, it is generating random noises here in some cases. Look at here, look at here, look at here. Okay, somehow if we are looking from afar, it will resembles like a cartoon, anime cartoon. But if you closely monitor it, then you will see that generator discriminator can already discriminate. Look at here, the face is not perfect. Okay, now after 20,000 update, the faces is something good, but in some cases, look at here, still there is the need to improvement. Okay, so after 50,000 updates, now whatever it is generating is little bit good, but still it need to update. Look at here, this is the false case. Look at here, it is a false case. Okay, so after 50,000 update, this is the output we are getting. So it will started with a random noise, and it has generated this, and based on that it will generate this. Okay, this is the training process of generator. Okay, now look at how does basically discriminator discriminate. So generator generated a tuna, and it's a target. Look at here, it's a target. Okay, so if we are simply looking now, so we will look like both are exactly same now. But now let's see. Look at here, what we miss actually. In this case, 1 pixel error is there. Look at here, here 1 pixel, and look at here. So 1 pixel error is there. So discriminator will discriminate it. 1 pixel error is there. Okay, target is this. It is 1 pixel error. Look at here. We don't have, we have this 1 pixel error. We have 6 pixel errors are there. Look at here. These are the 6 pixels error. And we have 6 pixels here error here. So it will minutely analyze the target as well as the generated images. It will learn to differentiate between these two. So what we are what looking like real to us, the generator will distinguish it's a fake. It's a training of generative adversarial network. Okay, now so it look at here another example. It's a training of discriminator. So how discriminator training basically does. So we will be having, these are the real examples. The real examples means output will be 1. Look at here. A scalar means from this we have generated some probability value, based on that we predicted the real, whether it's a real or fake. 1 means real, 0 means fake. So since we have taken, it's a raw, it's the actual input image. Okay, raw real images. So discriminator is predicting it as a real. Okay, so discriminator only runs to output 1. It won't learn to output at a 0. Okay, it's a try. Its target is to get a maximum probability for real. So maximum probability for real means near to 1 for real. Okay, and our target is to minimize its probability. Okay, so our target is to make the probability near to 0. Okay, so that it will detect the, it will fail. Okay, now in this case it is getting 1. Okay, why? It's input images. Now how we do it, our target, look at here, these are the real examples and these are the fake examples. Okay, so in this case the output will be 0, and for real examples the probability will be high. Okay, now how it will basically do. So it will try to generate the negative, it will try to generate the fake image, it will try to learn the fake image also. Okay, the fake image will be, look at here, if it's a real image the output will be 1. If it's a fake image it will be 0, because the probability will be 0, so we will call it a fake. Probability will be 0 to call it a fake, and our target is to that we have to generate for a fake image we have to generate a probability near to 1 that will look like a pretty real images. Okay, this is the training process for discriminator. Okay, so general algorithm is there, that given a set of a positive examples, randomly generated set of a negative examples. We will give a positive examples from a data set, negative examples generated from the generator. For each iteration, the discriminator D will distinguish between the positive and negative and try to predict the probability, and generate a negative examples by discriminator. Okay, with this function it will try to generate the negative example. This is a continuous process. Okay, this is, I have already discussed how it will do. Look at here, this code means these are basically latent vectors. Okay, this latent vectors will be given to generator, will generate the image. Okay, based on that image will be given to the this image will be given to the the discriminator will predict it one, and it will update. Okay, it will give the updates onto the uh, generator will update and try to predict more realistic images. This is another example. Okay, so I have already discussed, we have generator and discriminator, pros and cons. Easy to generate even with a deep model. It's a discriminator positive is considering a big it can consider big pictures also. Cons is it's a limited imitate the appearance, hard to learn, because hard to learn, now after 50,000 iteration we are getting a good results. Okay, generation is not always feasible in case of this. These are some common example. Okay, now look at here. It's a basically generator architecture. It's our latent vector. Look at here. We have to start from here and we have to predict this. Okay, so how it is? It's a most widely used generator architecture. How it is there? Look at here. From 1,000 vectors to we are generating features 4x4 1024 features. It's kind of a 1024 dimension of 4x4 vector. From this we are getting a 8x8 size matrix of 512 channel. From this we are getting 16x16 matrices of 256 channels. From this we are getting 32x32 of 128 channels, and from this we are getting 64x64 image of 3 channels. So it will be kind of a RGB image of size 64x64. So this is how this progression goes. We have started with the one vector and we have ended up with getting a matrix. Okay, this is a generator architecture. Okay, this is how generator training works. It's a man with the gloves, man without glasses, and it's a woman without glasses. So based on this example, it can generate a woman with the glasses. So it's nothing but the man with the glasses, it will be having a vector. A man without the glasses, it will be having another vector. So basically these two will be those vectors. Now know what are the vectors. So these are the vectors. Okay, so it will be having vector. So it will be having a vector. Okay, so man with the glasses and man without glasses. So when we differentiate it, so we will get something that will be a glass, and we will then fuse it with a woman's vector. Then it will, what you will get? You will get woman with the glasses. This will be the output. Okay, now there are different types of generative adversarial network. Vanilla chain is there, conditional chain is there, deep convolutional chain is there, Laplacian pyramid chain is there, super relational chain is there. Okay, these are different generative adversarial network. I am not going deep into this. Okay, because we don't have that much time. Okay, now let's take an example of this. It's our real life generative adversarial network problem that we are working on. It's a development of real-time marine visualization system under hazy rainy weather condition. It's a DRDO sponsored project that we are working, sponsored by NRB Lab, Naval Research Board Lab. It's a funded project. So what we have to take? We have to take hazy image, but what we are in marine condition. So right now we are working it's a first year. So the image will be hazy, and our target is to get dehazed image. Okay, so it is the kind of encoder decoder work, and it can done in a, look at here, encoder decoder. So it will be generator, and it will be a discriminator. Okay, so generator means from encoder and decoder type of things. Okay, from this, but in this case we are getting a hazy image. Okay, so from here we are dropping down to a feature, and from it's just a kind of reverse. Generator is, look at here, it was our generator where we have started with a vector and tried to constructed the image itself. And in discriminator, how we do? We try to get an input image and we to try to predict. It's just a reverse thing. Okay, we have taken kind of a discriminator at the start and generator at last. Okay, why? Because from the image we have to get its original feature. So features will be fine-tuned. Okay, and from the features we are trying to generate the dehazed image. It's another example that we are doing. Okay, now let's take another example, that is the generative AI example. Here it's a basically gen-based synthetic brain MRI image generation. So look at here, these are some real MRI images. Okay, so this is the model where original MRI image has been given to the conditional gen. It's okay, and based on the conditional gen, it generates the synthetic MRI images. So these are the original images, and these are the synthetic MRI images. Okay, so we are using generative adversarial network in medical data synthesis. Okay, that's why, because we have a data scarcity in the medical field. That's why we are using, so many people are using GAN-based data synthesis process. It's another example. It's a brain GAN. Okay, brain MRI image generation and classification framework using GAN architecture and CNN model. So look at here. It's a basically what here it is doing. It is taking brain real MRI images. Then it is doing both using vanilla gen. So from vanilla gen, it is taking the output, and from the output, it is using CNN, mobile net, ResNet to check whether the generated image is tumor and non-tumor. Okay, so this is the real in real MRI images, and it's a fake MRI images. Okay, so generative, why it is emerging trend in generative AI is because it's a basically major breakthrough. It's a deep learning architecture that can generate the that that can generate the things. Okay, that's why it is emerging. It's availability of massive data sets, and okay, and availability of GPU and TPU is there because we have graphic processing unit, we have tensor processing unit to compute. So computation power is very high, so we can design complex networks also. We have now advanced technique like RLF, HF. It's a basically reinforcement learning through human feedback. So human can give feedback and do the reinforcement learning. We have prompting. So these are the things. That's why this Gen AI is a emerging topic right now. Okay. Then things to keep in mind during Gen AI. First one is the lack of consistency. That is a major problem in Gen AI. We call it a hallucination. So hallucination means, so basically large language model, you can say, or generative AI models or GAN based models, it will hallucinate. Each time for a same input, it may give you different output. So their answers will be widely different. Okay, that's why in sometimes when you are giving GPT, chat GPT you are using, you are putting some question. So then chat GPT will give you two versions of answer. Okay, why it is giving two versions of answer? It is taking feedback from you, which version is a better. So that will be basically reinforcement learning. We have human feedback. Okay, so you will feedback, so that from the your feedback that generate that GAN model working within the GPT. Okay, it will know which is real. Okay, which is looking more like a real, so that it can update itself. Okay, and that's why it is hallucination. So for each time it may generate widely different answers. There is a bias. Why bias? Because we don't know na, on which data set our model has been trained. So if data is biased, so data has been done, model has been trained on data scrapped from the internet. Now if the data from the internet is biased, then the decision will be biased. Interpretability, there is a very difficulty in interpretability. You don't know which latent vector, which position you change, then the entire output will be changed. So how response has been generated from the latent vector, it is not explainable. Real-time knowledge is not there. Why? Because it has been trained on data. Now it's data. If the time has been moved ahead and data was, let's say it was a past data. So if you are using this model that has been trained on a past data, it might not give you the real-time answer. That is the main problem. Then there is a memory utilization problem is there, because if it has to train on that much amount of a data, then it has to learn the knowledge, and it needs memory. Then there is engineering challenges also there. So these are the things that we need to keep in the mind while uh, this uh, working with a Gen AI. So up to this point, if it is clear, you can ask me if it is clear or not. Can you tell me if anyone is having any doubt? You can ask me. Okay. Now, potentials of generative AI. These are the things where we can use generative AI: low resource language, inclusion, accessibility, personalized content generation, AI tutor, intelligent assistant, accelerating scientific discovery. These are the areas where we can use generative AI. Okay. Now, let's go to the part third, that is called large language model, or LLM. Okay. So basically, what is a large language model? Look at here. So large language model, we call it large language model. So basically a model that has been dependent on a language. So voice, text, and image can be the input, and in output, it can give you the question answer thing. It can give you the semantic analysis. It can generate the image caption. It can do the object recognition. So basically, LLM models are advanced AI system build on deep networks designed to process and understand the human-like text. Okay. So now let's simplified version of LLM training process. Look at here. So whatever input we are giving, so first it will tokenize it. Look at here, the tokens it will identify. Then from the token, it will try to generate the embeddings. So we have already see how embeddings has been generated. So these embeddings will be given to a pre-trained transformer model, or GPT. Okay, model. This model will, based on this embeddings, this will try to predict the output text. Okay, so it is called encoding process. It is called decoding part. Okay, that is the basic version of LLM. Okay, now look at here how it's a working of LLM. Input text is there. it will be given in form of embeddings and positional encodings. So we will give two things as an input, embeddings. So it will be embeddings of text embeddings, and positional encodings give you the position of each word. We will pass it to the encoder block, then it will pass to the decoder block, and it will generate the output. How encoder and decoder block works, we will see it later. Okay, so encoder block and the decoder wall we will discuss in detail. Okay, so the input embeddings. So here we have input embeddings. So input embeddings, basically it's a basically original text converted into the numeric information. Okay, that is the input embeddings. What is the positional encodings? So it's basically give you the order of words. Okay, so position of each word will be there. Okay, now we have a auto encoder. So here in auto encoder we have two things. One is known as self attention, another one is known as feed forward layers. So self attention is what this makes LLM unique. Okay, so self attention understand the relationship between words in context. Okay, whatever embeddings is there and positional encoding is there, the self attention layer will basically learn the relationship between each word and their position. Okay, then we have feed forward layers capturing the complex pattern between the embeddings and positional encodings. Then we have decoding. So based on the generated patterns, it will now try to generate the responses. Okay, this is the working of LLM. Now let's take an example. Now embeddings in natural language processing. Look at here. If we have given object 1, object 2, object 3, we can use any embedding models. It can be one-hot encoding, it can be globe to back, it can be globe. There are so many techniques now where you can generate the embedding from object 1. It means it can image, or it can be a text. Okay, from object 1 it will generate vectors like this. Okay, vectors like this. So these are called word embeddings. Okay, then from word embed, so it will look like this. For cat, format, on, it will look like this. So it will be this embedding will be given as an input to model. Now, what is a word embedding in NLP? We have already discussed. Okay, so I have already discussed the one-hot encoding and everything. So that's why I'm skipping this. So what is word embedding basically? So word embedding is approach for representing word and documents. Okay, in form of a numeric vector. Now let's say happy, sad, so it will be look like this. Sad, it will look like this. Sick or excited, it will look like this. So these are the embeddings. Okay, so this is the called word embeddings, where a word or object or a sentence will be embedded or represented in form of a numeric information or numeric vector. Okay, this is the example. So basically we will be given word as an input, it will be a numeric representation, and it will be used in training or inference. Okay, now techniques used in embeddings in NLP. There are so many techniques. So basically 3 different classifications are there. Frequency-based embeddings, bag of words we have already seen. TF-IDF we have already discussed. Co-occurrence matrix is another frequency-based embedding is there. Now prediction-based embedding is there, word to WAC. Okay, collection of bag of words, skipgram, globe, fast text. These are some examples. Okay, then contextualized word embeddings is ELMO, BERT, GPT. Okay, these are some examples. So these are the techniques from where we can convert a textual information to a numeric value that will be given as an input to our transformer model. Okay, now let's take a globe. Okay, so we have written it is a nice everything, good evening, it is a nice evening. It has been written now. So it is a nice evening, good. Okay, so these are the different words. Look at here, it is a nice evening, good evening, it is a nice evening. So different words are it is a nice evening, good, it is a nice evening, good. Okay, so this how a matrix has been created in case of a globe. Now how globe does, it checks whether it has been there or not. Okay, look at here, if it and it is there, so for it and it cannot be occur simultaneously, that's why it puts 0. Okay, now look at here, is and is, it is 0. Okay, now is it, so is it means where if is and it is just occurring simultaneously to each other. Look at here, is it has been just occurred simultaneous to each other. Is it has been just occurred simultaneous to each other. So it is putting 1 plus 1. So it has been occur once, so it has write 1. It has occur once, it has write 1. Okay, now in second case, a it, look at here, a it is there. Okay, so look at here, a is there, it is there or not. In this case, 1 2, a it is there na, a and it pair is there. Look at here, after one word is there, so between there is a distance has been changed. Now it and a, there is a distance. Now distance is 1, has been changed. So that's why it is adding 1 by 2. Okay, so distance has been just half. Now let's say it is now in this position, it is just adjacent to each other, so it is adding 1. So it becomes 1 and half and 1. Look at here, a is it is it is occurring adjacent to each other, so 1. And look at here, a is it is occurring 1 apart, so it is 1 by 2. Now in this case, look at here, nice it, so nice 1 2. So after sorry, nice is there na, nice it is nice 1 2. So 1 and 2 position is there. So when the distance is 2, it means 2 words in between nice and it. Look at here, nice and it is 1 word, and nice and it is 2 word distance. Okay, nice and it is 2 word distance, nice and it is 1 word distance. So 2 word distance, so it becomes 1 by 3, and 1 word distance, it become 1 by 2. So 1 by 3, 1 by 2. So in this way, if the distance is 4 words, so it become 1 by 4. A 3 word, it becomes 1 by 4. Okay, so distance is adjacent. So 1 distance between them is 1 word, so 1 by 2. Distance between them is 2 word, then it will be 1 by 2. Yes, or 1 by 3. Distance between them is 3 word, then it will be 1 by 4. So in this way, it will compute this globe to VAC vector. Okay, and this embedding will be used. Okay, now popular LLM models are there. We have ChatGPT, we have Gemini. Okay, we have Cloud A, Llama. We have Mistral 7B. Okay, we have BERT, Roberta. We have Mural BERT. We have Acceleram. We have Blue. These are some common examples of LLM. Okay, you can use all these things. Okay, now the main thing is a transformer model. Now, what is a transformer basically? So transformer model is an architecture basically. Okay, now this transformer models text sequence as an input, okay, and produce another text sequence as output. That's why transformer is so much popular. Okay, so GPT is a transformer model, generative chat GPT, that is pre-trained transformer. Okay, now it will take entire sentence as an input at once. Now, in case of RNN and LSTM, how it was happening, we were taking word by word as input. Now, we were giving word by word as input. We have already seen in our first class. Now, in case of a transformer, we will give entire word at once as output, as an input. With this, we will give their positions also. Okay, so why transformer is a better version? Because it can take entire input at once and try to generate the output in form of a text. So we will give text as an input and we will get text as an output. Why transformer are powerful? It can model long range dependency better than RNN and LSTM. Okay, it's a easily parallelizable, faster training is there, it's scalable, large data set and massive data models are there. GPT, Plum, Gemini, Cloud, these are transformer models. Okay, now let's discuss how transformer model works. So we have a transformer, we have written you are welcome. Okay, this entire input will be given directly to the transformer model at once. In case of a RNN or LSTM, we have to give U first, then R first. From U to we will predict R to we will predict welcome. That was the process now. Okay, from U to we will predict day, and R to we will predict nada. Okay, our target is to translate in this you are welcome to another language. Okay, so in transformer, it will give entire input at once with their positions also. We will see how positions will be given, and it will generate the output in a form of another translated thing. Okay, up to this point, it is clear. Okay, now look at here. It is an input, it is a target. Okay, so target means denada, it is a target. So during training process, input will be given. Okay, so input will be in form of embeddings. It will be your embeddings and positional encoding. Then we will be having encoders, then encoder will be trained, and we will be having series of decoders. So the final encoder will be give feedback to all the decoders. We will see what are the architectures of encoder and what are the architectures of decoder. And for target also, it is a target. So for during training, we need to give the pair of input and output. So our target, we will be generating the embeddings and encoding, and it will pass to the decoder. And based on that, it will generate the output. Okay. Now look at here, we have different type of encoders. We have first encoder, so it's called it's a basically decoder encoder architectures. So first one is your encoder portion is this. It's a feed. Here we have a self attention block, then a feed forward network is there. So we will call it an encoder. How self-attention works, we will see. How feed-forward work, we will see. Okay, this is called encoder architecture. In one encoder architecture, there will be one self-attention block and a feed-forward block. Okay. In case of a decoder, we have a self-attention block, we have a encoder-decoder attention block, and we have a feed-forward network. Okay. Now we have another encoder version is there. Okay, we have this self attention with a skip connection is there, we have normalization is there, we have feed forward with a skip connection is there, we have a normalization is there. So these are the different encoder decoders we use in a GPT models. Okay, so these are, look at here, we are using multiple encoders decoders now. So these are the architectures of encoder and decoder we are having. So here we can get now, we have two different things. We have a feed forward network, we have a self attention, and we have a layer normalization. Up to this point it is clear. Okay, so up to this point, a decoder will contain a self attention followed by an encoder decoder and a feed forward network. Okay, now let's move ahead. How this thing work? Okay, so what is this self attention do? So look at this example. Okay, the cat drank the milk because it was hungry. Okay, so how? First, before starting, let's discuss this boy holding a blue ball. Okay, now the example, while processing the word, the attention, that attention mechanism, what attention do we are doing, we are try to figuring out now. So that while processing a word, that attention enables the model to focus on other word and their relationships. Now in this case, the focus is on a ball. Okay, so ball, what? It's a blue. Okay, look at here, its current relationships is it's a blue, it is saying that it's a blue ball. Okay, now that blue ball, or that ball has been holding, someone has a holding. So, and there is another relation that it's a boy. Okay, so basically a ball is closely related with the blue. Okay, and holding, because it's a near relationship, and it's a little bit related to sorry, boy is not related, but blue is related to somehow boy. Okay, this is called attention, that where we will establish the relationship between different words and their orders. Okay, now let's take another two example. Now consider this: the cat drank the milk because it was hungry. Another, the cat drank the milk because it was hungry, it was another milk. Oh, okay, now let's consider this example. Okay, the first sentence, the cat drank the milk because it was hungry. Okay, the word, look at here, it word. Okay, it word refers to whom? It refers to cat, na? Because the cat said, now let's say, now during RNN or LSTM, what happens? We will feed this dog separately, cat separately, drank separately, milk the separately, milk separately, because separately, or eat separately. Na? Now, since this eat, it is not related to there, na? Because we have given separate information. So how we don't know that it we are referring to the cat? So that's why, look at here, this it is highly related to the cat. Okay, the first sentence, the word it refers to the cat. So that's why it is the relationship, the attention is there. Okay, then there is a, it has been little related to the milk it. Okay, this is the, this is thing. And another version, look at here, the cat drank the milk because it was sweet. Okay, same little, almost similar sentence, but look at here, in this case the it was related to cat, attention was given to cat. In this case the attention was given to the milk. Okay, now in this case the cat drank the milk because it was sweet. Now it will be highly related to the milk. Okay, so attention was given to the milk, it means it is referring to the milk. Now let's take the this output score. Okay, now what happens in this case? We have this score is there. Okay, now we have given the cat drank the milk because it was hungry. Okay, so now it was the relationship attention score, where you can look at here, the cat will be highly related. Okay, so while processing the word it, the first score highlights the cat. Okay, while the second score highlights the, look at here, second score highlights the hungry. Okay, and so when it decodes the word it, by translating it to a different language, for instance, it will incorporate some aspect of both cat as well as hungry. Okay, that's how attention work. Okay, up to this point it is clear. how attention works. Okay, now let's take a training of a transformer model. So this is a basically a basic architecture of a transformer model. Look at here. We have, na, our input was you are welcome, and the actual outputs were Danada. So we have to done the training. Okay, so it's a encoder part, it's a decoder part. Okay, now in the encoder part, we have two encoders, and decoders, we have two decoders. Okay, decoder 1 and 2. And na, architecture of decoder, I have already explained. Look at here, encoder and decoder architecture. It's an encoder decoder architecture. Okay, now let's see. In the first step, what happens? We have this word. Okay, you are welcome. From you are welcome, it will generate its word IDs. Okay, so word IDs means it's embeddings. You can use any embeddings. Okay, it can be a Glove embeddings. It can be another embeddings. You can use a deep learning for the embeddings also. It can be one-hot encoding also. It can be a BO back of words encoding also. So whatever encoding you are using, you can use here. Based on that, it will generate the embeddings. Okay, so this embeddings will be generated. At the same time, your position encodings will be generated. Okay, positional encoding will be generated. Now these two, embeddings and positional encoding, both embedding and positional encoding, both will be concatenated. Okay, and that will be given as a input to the encoder 1. Okay, so it's a first stack of encoder. Okay, this first stack of encoders basically process the input and generate a encoder representation. Okay, it will process these two things, embedded and positional encodings. Okay, embeddings and positional encoding, and it will generate a first encoded output. This first encoded output will be given as a input to another encoder. That another encoder will generate the second encoding output. Okay, this second encoding output will be given as an input to two decoders. Look at here, and how decoder works. Now here we have target sentence. From there we will generate its embeddings and its positional encoding. This positional encodings and these two things, it will be concatenated together, and it will be given as to the decoders. Okay, it will be given as a decoders along with the encoded output. Those two will generate first decoder output. Then the first decoded output along with this encoded output will be given to the decoder 2. This decoder 2 will be given the second decoder output, and that will be passed through the linear layers and softmax function to generate the word probabilities. That first word, what will be the position, what will be the best word for the first position, and what will be the best for suitable word for the second position. And this how it will generate the Danada. Okay, up to this point it is clear. It is the training process. Okay, now how inference in transformer model does. So inference means it's a kind of a teacher forcing, or it's kind of a testing process. Okay, so now how inference will be the flow will be, look at here. The first you have given you are welcome as an input. Okay, so you have given the you are welcome as an input. Now in this case it has begin. Now look at here, there is nothing here now. Now it will be a start vector. So a star vector, it's just to initiate the process. This is the start vector. We are not passing any target output here. Okay, now how it works. You are welcome given, its generated embeddings will be generated, its positional encoding will be generated. Both will be concatenated and passed to the encoded output. This encoded output will be passed to the encoder 2. This encoder 2 output will be generated and passed to the two decoders. Now what happens? We will generate a start word. So a start word, it's basically a starting point. Okay, so it's just a start of sentence, or we can call it, it will be a start of the sentence token kind of thing with a position encoding. Okay, now these two will be passed to the decoder. Now along with this, the encoded output, it will pass to decoder 1. Then decoder 1 will give some output. That output along with the encoded output will be given to the decoder 2. It will generate decoder 2. Then there will be linear layer, sequential layers and softmax layer will be there, and it will generate word probabilities. Okay, and that in the fifth step, that output layer, this softmax, these two are called output layers. Okay, convert the word probabilities and produce an output word. Now it produces day. Now this day will be given as an input to this. Now this start along with earlier it was start. Now in the second iteration it will be start and day both. Now start and day both will be there. Now it will start again. This start and day both will be there. This start and day both, it will be generating embeddings will be generated. Positional encoding will be generated. Again passed to decoder. Again passed to decoder. Then the output layers will generate. The first word was day, and next word will be nada. So in this, how it will generate it DNADA. So it takes entire sentence as an input at once. So because so that it can generate the relationship. Okay, up to this point it is clear. Up to this point it is clear. If you are having any doubt, you can ask me. Okay, it's a basically transformer classifier architecture. Look at here, a transformer. If we are using transformer as a classifier, then we need to add a classification head that can generate a positive sentiment and negative sentiment. Okay, rest of the thing will be same. It will be series of encoder blocks. If we are using transformer model as a language architecture, then we need to use LLM model, language model here, and in the top. Okay, now transfer model, how they are better than RNN? Can you tell me why they are better than RNN? Okay, so in this case, LSTM, look at here, you are welcome. At T1, at a T2, at T3, whatever output generated will be given as a input to LSTM. Whatever output generated will be input to given to the LSTM. So there will be no dependency upon the word now. So it was challenging to deal with the long range dependency between the words. Okay, but transformer process the input sequence sequentially at a time. That's why it can map or establish the relationship between different words. That's why transformer is a better than LSTM. Okay, up to this point it is clear. Now transformer model embeddings. Look at here how embeddings and positional encodings are done. So look at here. So these are the you are welcome pad. We have written this now. So here it's look at here, its word embeddings will be there. Okay, so word embeddings, word embeddings, word embeddings, word embeddings. These word ID and these are the positional IDs, which position these words are occurring. Position 1, 2, 3, 4. So these two will be embedded together to generate the input embeddings. Okay. Now these are the input sequence. Look at here, embedding, position, encoding. You are welcome pad, and at the same time we have to what we can set. We will pass the positional embeddings also, like this, position 1, 2, 3, 4. At the same time, these are output embeddings. It will be start, first day word will be predicted, then start and day will be passed, then nada will be predicted, then start day nada will be passed, and pad will be predicted. These are the embeddings type in transformer models. Now these are the positional encoding. So do we have time, or we can stop here? We can start here from next day. Can anyone tell me? Can anyone tell me? Can we stop here, or we can?
Yeah. I think yes.
Tomorrow we will start from this point also. I will take half
That
an hour. Tomorrow I will take half an hour to discuss this transformer model. Then we will basically do a live demonstration. Okay, we will, because we have to discuss that what we call it capstone project now. So in capstone project we will try to build a model from scratch, and I will
Thank
try
you.
to
Thank you very much. Thank you.
okay. Okay, so we will meet tomorrow at the same time. Thank you.